Hello everyone. In this video what we are going to look at is angle of elevation and angle of depression. But before I give you the definition of what is angle of elevation and also angle of depression, I am going to try and demonstrate what these are. Now, one thing that you must know about angle of elevation and depression is that it has to do with your eyesight. It is all about your vision, right? So, like for example, if you look straight ahead at an object, right? And then let's say that a plane is flying in the air and then I look up, then angle of elevation is formed. But let's say I am now looking straight ahead, right? And then I now look down on an object, right? Then that angle that is formed between those two lines of vision is called angle of depression. But let me give you a demonstration on the board. Let's say you have an eye here, right? This is an eye, representation of an eye, right? And you have two objects. You have object number one, and you have object number two, right? Now, let's say that object number two is directly in front of your eye line, straight ahead. Let me write it some further, up more. Object number two. So these objects, this can be a plane, maybe a house or something. But this object number two is directly in front of your eye line, right? And I am going to draw a line from your eye line directly to object number two. So this is a horizontal line directly in front of your eye line. There's a special name that we give to this line, and this line we call it the horizontal line of sight, right? The horizontal line of sight. So we call this line the horizontal line of sight. That's when you're looking straight ahead, right, at an object. So let's say that now your eye line, you just look up at another object, right, creating this line. This line, we give it a special name. We call it the inclined line of sight, or you can call it the line of sight looking up, right? So we have the horizontal line of sight and we have the line of sight looking up, or what we call the inclined line of sight, right? But note that between these two lines of sight, so between these two lines of sight, there is an angle that is formed. Here we have an angle. Let's call it theta. So there is an angle that is formed between both lines of sight, between the horizontal line of sight and also the line of sight looking up. What do you think we call this angle? This angle is called angle of elevation. Right? So that's the angle of elevation there. Now, with all of these information, can you put it together and give me a definition of what is the angle of elevation? Yes, you can. You could simply say that the angle of elevation is the angle formed between the horizontal line of sight looking straight ahead and the incline or line of sight looking upwards. That's basically what the angle of elevation is in a nutshell. Let's say that you have another eye, right? Have another eye. And this time you're looking straight ahead at object number 3. Right? What is this line called? It is still the horizontal line of sight. Right? Still the horizontal. But now you're looking downwards at an object, and you're looking at object number 4. Right? So you're looking at object number 4. What do you think this line is called? This line is the line of sight looking down. Right? So this line here is the line of sight looking down, but you still have the horizontal line of sight looking straight ahead, right? Note that there's an angle that is formed here. Let's call this angle beta. So there's an angle that is formed here. But what do you think is the name of this line? Angle here, the name of this angle. There's a special name. It is the angle of depression. Right? So, whenever you're looking straight ahead and then you look downwards, there's an angle that is created. And that angle is called the angle of depression. Whenever you're looking straight ahead and then look upwards, there's an angle that is formed, and that angle is called angle of elevation. So put it together now. What is your definition of angle of depression? It is simply the angle of depression is the angle formed between the horizontal line of sight and the line of sight looking down. Basically, that's what is the angle of depression, right? Now, there's another thing that you need to know about the angle of elevation and the angle of depression. The angle of elevation is equal to the angle of depression. Let me say that again. The angle of elevation is equal to the angle of depression. They form what we call alternate angles, or what you popular call Z angles, right? Cool? So let's look at an example, right? Let's say that you're here, you're standing. Let's say that you're standing on a ground, right? And your height is about, to your eyesight, is about 3 meters. You're 3 meters tall. And you have a tree. You have a tree, right? Somewhere here. Something looking like this. Right? You have a tree. And you want to determine the height of the tree. Don't know the height of the tree. That's what you want to determine. Right? But you know the distance from where you're standing to the tree. You know that that's 100 meters. Follow me? So you know the distance from here to here is 100 meters. You also know that your line of sight looking across to the 3 and your line of sight looking upwards at the top of the 3, you know that angle. You know that angle is 30 degrees, right? And you're asked to use this information to determine the height of the tree. How would you go about doing this question? Now, because you know the angle of elevation, which is 30 degrees, you can go ahead and find the distance of the 3 from this section here. From this section to the top of the 3. So you can find this height. You know that? You can find that height because you know this length here. You know that this is 100 meters. You know that this is 100 meters. That's what they tell you. Now you could call this height here x, you know, let the height here be x. Now you could use the trigonometric ratios to find this. If you have an angle, you don't know the opposite length because you know that x here is opposite to this angle. You know the adjacent side. That sounds like tangent, right? So we know that tan theta is equal to the opposite length over the adjacent length. What is theta in this case? Theta is 30, right? So we know that tan 30 is equal to the opposite length, which is x, all over the adjacent length, which is 100 meters. Can we find what x is? Yes. Multiply both sides by 100. So if you multiply this side by 100, you get 100 times tan 30 is equal to x, right? And you can put this on your calculator, right? So if you put this on your calculator, you know that x is therefore equal to, and you just put that on your calculator. See that that is 100 multiplied by tangent of 30 degrees. Tangent of 30 degrees, and that is approximately 57.74, correct to 2 decimal place, right? So that's meter. So we know that the distance from here to here, that is 57.74 meter, right? But they didn't ask you for the distance of this part of the tree. They asked you the distance for the entire height of the tree. But you know the height of the person. The height of the person is 3 meters. So therefore, the height of the tree, therefore, the height of the tree is the height of the person, don't it? Which is 3 meters plus the height that you just calculate midway the tree, which is 57.74 meter, and that is 57 plus 3, that was 60.74 meter. So that would be the height of the tree there. So let's say now you're standing on top of a building, right? So you are here. You're standing on top of a building. Now the building is on the ground, right? So this would be a representation of the ground. And let's say that there is here on the ground you see an object on the ground. There's an object here. And you're looking down at this object. So from your eye line, you're looking straight down on that object there. Right? You know the height of the building. You know the height of the building here. Say the height of the building. Say the height of the building is about 90 meters. Right? And the height of the person here is about 2 meters. Right? And let's say the angle, yeah, this is your horizontal line of sight. So this is your horizontal line of sight, right? And you know the angle of depression, because when you're looking down, that's an angle of depression. So you know this angle here. This is your angle of depression. And you know that this angle is 40 degrees. And they ask you to determine the distance between the foot of the building and where the object is. So they wanted to determine this distance here. So they want this distance. So let's say we don't know this distance, so this distance is x meters. Right? But they want us to determine what x meters is. How would you go about doing this question? Now, one thing that we know that the angle of depression is equal to the angle of elevation. So that means this angle here, which is the angle of depression, is equal to this angle here, which is the angle of elevation if you're looking up, right? So we know that this is 40 degrees, so that means this is also 40 degrees. Another way to look at it is to say that the horizontal line of sight is parallel to the ground, right? It is parallel, and this is a transversal, right? So where you have parallel lines and a transversal, you have alternate angles are formed, or what you call Z angles are formed. So they are equal. We know that Z angles are equal, or alternate angles are equal. So notice here, this is a Z. So these two angles are equal, right? So that's another way you could look at it, right? Now, we would have known an angle, so this is 40 degrees. We know that this opposite to this angle here, this is, from this angle to this side, this is the opposite side, so we know that over here is opposite to the angle, right? We know that the building and the ground, they create a 90 degree, right? They form 90 degrees, so you can see the triangle, right? Now, this is a right angle triangle, basically. So we can use the trig ratios, right? We know we have opposite length to this angle here, and this is now with our adjacent side. So opposite adjacent, which ratio comes to mind? Tangent, right? So we know that tangent of 40 degrees is equal to the opposite length. Well, what's the opposite length? It is 90 plus this 2, right? So it is 92. So this is 92 over the adjacent length, which we don't know, which is x. Right? Because that's what we want to find. We want to find what x is. Right? So here, if you multiply both sides by x, then you end up with x times tangent of 40 degrees is equal to 92. Then divide both sides by tangent of 40 degrees and divide this side by tangent of 40 degrees. We now know that x is equal to 92 meters divided by tangent of 40 degrees. So x, which is the distance from here to here, is equal to, put that on a calculator, so select your fraction bar, and that's us 90 divided by tangent of 40 degrees, and that gives us a distance of approximately 107.3 meters, carried to one decimal place. Meters, right? Right? So that's how you would calculate the distance of x. So right? So now, if you notice here, the angle of elevation and depression has a lot of real life applications. So we can use it to calculate real life distances and things, right? Thank you for watching. Thank you for watching. I hope that this video would have helped you to understand the concept of angles of elevation and depression, right? Do enjoy the rest of your day, and remember to like, subscribe, share. Thank you.